right. Today what we're going to do is we're going to look into the world of artificial intelligence or gaming AI. And we're going to investigate a few steering algorithms today. So there are different aspects in AI, and we're going to focus specifically on steering for this lesson. And we're going to start off with a few techniques. One is called seek and flee, which we're going to start with now. There's also pursue and evade, and there's also wandering. We're going to start with these 5 different techniques, but we're going to start off now with seeking and and fleeing. So what I have here is I have a pre-built project here. If you want to follow along, the idea is that have a character and also have a cube, and have controls set up for the character so you can move the character along the screen using just left, right, up, and down, or WASD keys on the keyboard. But right now I have it set up so we're going to do some seeking. All right, so I'm going to hit run. This is the end product here, and then we're going to build it out together. So just letting it load. All right, and you're seeing here the cube is just running straight to the character. Now let's do some moving around here just so you can see. I have here the scene view on purpose because it gives you a better view of what's going on. And I also have Cinemachine set up so that it follows the character, but rather than give you a narrow zoom level, I thought the scene would be a better view here. So we'll be using this, relying on the scene view a lot today. And you can see that as I move my character around, the cube is actually turning to face the character. All right. And so now let's try fleeing. So I click on flee mode. Notice that it's actually running away from the cube. Now I'm going to get my character to come back. Actually, we'll probably have to restart this, and you'll see flee mode a bit better that way. All right. So let's hit the flee, and now watching the cube run away. Oh, hit the flee in the checkbox there, and it's running away, so better keep up with it. There it is. Now you'll notice that it's changing direction as I change direction right there, and so you can see there that the cube is actually running away from Fembot, and when I moved Fembot around a little bit, it actually changed direction. So this is seek and flee, and one thing you'll notice is that seek and flee are actually the opposite of each other. So the algorithm, interesting enough, for seek and flee is just a matter of just multiplying one line of code by -1, and you have your flee. All right, so we're going to build out the seek. We're going to add the functionality at the end to do flee. So first thing we need to do in this project is add a new script called seek flee script. So first I'll take away this end product here, and you can see that we're going to work with that in a moment. So here's the project we're going to work on. We only have Fembot here. We have a plane here that's 3000 by 3000, and I'm going to start off by actually adding a cube. Even before adding the script, I'm going to add a cube. So I'm going to go to 3D object, cube, and we'll just place the cube maybe a little bit behind Fembot there. And the cube, it actually, if you look at the game view, actually, it blends in too much. So you can see there, I want to change the color. If you can change the color, go for it. If not, it's no big deal. So I'm going to just change the color to be like a black. So I actually have black there as one of the materials. And there we go. So it's a little more visible to us. Now I'm going to move it back a bit. The important thing about this cube is that we want to maintain it to be a Y of 1. Okay. We just want it to maintain it that it's at this particular level. And so that makes it easier for us to work with here, because you're going to find that with forces and gravity and all that sort of stuff, it's going to actually move below the plane. It'll move high up in the air, and then it'll look really odd in terms of how we're chasing and evading, or fleeing and seeking between the two objects here. All right, so we'll leave it as the name cube. Now, like I said before, we need to add a new script. So I'm going to go back to project here. I'm going to add a new script. So I'm going to hit the plus sign there, go C# script. And like I said before, we're going to call it seek flee script. All right. So let's open up the script here. We'll say seek these scripts. So it should have automatically launched Visual Studio for you. If not, just double click on the script and get Visual Studio to open so that you can actually start editing this script. All right. Now, first thing we'll need are some variables. Okay. And so we'll focus purely on seeking right now. So I'm going to say public game object, and we'll call it character. Right? And public game object target. Now, the names will feel a bit misleading because of what I'm using to do this. Like, the character in question here is going to be the cube, right? You might be thinking intuitively character, the actual fembot object, a character there. And then target you would have thought would be the cube, but this is the way we're setting it up because I added movement to keyboard movement to fembot. So that's why we're using the reverse of these names. So again, character is the cube, target is fembot. So we'll be chasing or seeking fembot here. Now we're going to add a few variables here. All right, we're going to need a private vector3 for velocity. We're also going to need some constants. So I'm going to say public. We can make it private. You can make them public so that as you're tuning and testing. So let's do that. Let's make it public. You can adjust these numbers in your editor as you're running and testing to see what a good set of numbers are for your AI here. So I'll say public float mass is equal to 15. And then we'll say public float max velocity. We'll set it equal to 3. And we'll say public float max force equals 15. All right. And so these are 3 constants, mass, velocity, and force, that you can fine tune because we made them public. You can fine tune them in the editor as you're running. So you can see what's the ideal set of numbers. These I found to be ideal set of numbers. As you saw from the demo, was good enough. But hey, you can play around with these numbers on your own time and see what works for you. Now we're only going to work with start and update for today in this script. So particularly, we'll use start and we'll say velocity is equal to vector3 dot 0, right? Just to initialize it to be a 0 velocity. Now, we'll do the rest of our stuff in update. All right. And what we're going to do is, now in terms of what you saw in the demo, we're using basic physics here: position, velocity, time, mass, force, to try and calculate and figure out how we're going to get to our current position to where fembot is. So that's what we're doing, right? So right now we need a desired velocity. So we're going to say vector3 desired velocity make sure I spell it right. We'll set it equal to be the difference between the target and the character in terms of position. So we'll say target.transform.position subtracted from character.transform.position. All right. So it's just a difference between the two. All right. Now we'll say desired velocity is equal to desired velocity dot normalized times max velocity. And this is where you can fine tune max velocity to see how it works. So the idea is that we have here a position. We want to convert it to velocity. So what we're doing is we're multiplying it by a normalized value. All right, normalized numbers are between 0 and 1, or like a setting that is easier to work with. That's the whole point of normalization. And then we'll multiply it by max velocity. So we have our scaler here to scale our speed in our editor and to ensure that we get the right number. All right, so we have here our desired velocity after being normalized. Now we need a steering vector. So based on where we are and our desired velocity, we're going to create a steering vector here by saying vector3, call it steering, is equal to desired velocity subtracting velocity. So the actual speed at which we're proceeding. And let's clamp it down based on the applied force. So we'll say steering is equal to vector 3 dot clamp magnitude of steering, and length will be based on max velocity. All right. I mean max force. We're clamping it from between steering and max force. All right. Now we're going to divide our clamped steering vector by mass. So we'll say steering slash equals mass. All right, based on the mass that we're applying. So you change the mass, you fine tune the mass in order to adjust your seeking behavior. So if you have like a big burly character, let's say named Big Boy or something, they're not going to move as fast, and then they shouldn't be moving as fast, and therefore mass should be much higher. So you have a slower seeking ability. And may not even catch up at all if your character is super fast. But if you have like a tiny little road runner and it's supposed to be super fast to seek you out, then mass should be much smaller. So this is where you can fine tune mass to be something that will work for you. And accordingly, force, if you wanted to have maybe you're in a different environment, maybe you're in space, and maybe force should be higher because in a vacuum environment you might be able to chase faster, right? No drag, no friction happening in space, right? So things to consider as you're adjusting max force, mass, and max velocity. All right, so now let's scale it by clamping it again. We'll say velocity is equal to vector 3 dot clamp magnitude again. All right, we'll say velocity plus steering, so we'll apply it to our steering, comma max velocity. All right. So now we actually have a steering vector that we want to go to. All right. Now now we've been dealing with the velocity, but we know that distance that we want to travel is just velocity times time. So we're gonna say now we'll apply this to our character by saying character dot transform dot position. So up until now we've just been calculating where we want to go, and now we're going to apply it to our character. So we're going to change the character's position by saying plus equals velocity times time dot delta time. All right. So now that we've applied this to the character, now we know that this is where we want to be. All right. So we're going to say character dot transform dot position equals a new vector 3. Oops. Let's try it again. Is equal to new vector 3. Now this is to aid the character in being able to look at where we're going, but more importantly, actually, we're doing this additional step because I want the character to be clamped at a height of 1. So we're doing this extra step here. All right, so we're going to say new vector 3 character dot transform dot position for x comma 1 for y. All right, you want to keep it at 1 because there could be an instance as you're moving around, it could get sort of pushed up in the air or pushed below the floor. We don't want that to happen. So I'm doing this extra step here. It's not technically necessary, right? If you add in features like gravity and rigid bodies and so on, you wouldn't have to do this. But I didn't go that far into doing this with my little play area here. So that's why we're clamping it to 1 essentially. So we're saying y is 1, and then we'll say character dot transform dot position dot z. All right, so this is going to hold it down at y of 1. So this extra line, it's not technically necessary, but it's needed for our particular application today. And then finally, let's get this thing to move forward. So we'll say character dot transform dot forward is equal to velocity dot normalized. So this is going to say make it so, move in a manner towards the character. All right, so this is what we have here. We have our this is all we need to do a seeking algorithm in order to get our cube to chase after fembot. All right, now the trick is to apply all of this to our game. So what we're going to do is I'm just going to hit save. All right, save that script. We're going to switch over to our editor. Take a moment to refresh there. All right, and so what we'll do now is we will add this new seek flee script to our game script object. So I'm going to click on game script. So I already had a game script object already created, all right, just to be the manager of our scene. So I'm going to hit add component, all right, and I'm going to add seek flee script. All right, so if you don't already have one, you'll need to create an empty and add an empty game script object to it already. This script I already have game scene script object. This was meant for controlling the direction and movement of fembot. All right, so we have that seek flee script is here, and now I have character target. So character will be cube, and target will be fembot idle. All right, and you can see I have mass, velocity, and max force that you can fine tune as you're playing with it. So let's hit Control S to save my scene here. All right, and open up my game tab there so we can see there's fembot, and just hit play. Make sure I'm clicking within game so that it's in focus. And there you see the cube has moved towards fembot. Now let's try moving fembot around. So you can see there, the cube is chasing. And you notice that the cube is actually turning to face fembot. Right? So you can see that's what's happening. It's chasing, or it's seeking out fembot. Right? So that's seeking. Now, a moment ago, I said, or earlier on, I said that seeking and fleeing are opposite actions to each other. So the beauty of it is that we don't have to create a brand new script to get fleeing up and running. We can actually take our existing script and modify it slightly so that we can do some fleeing action here. So we're going to revisit our script here, and we're going to add a variable. All right, a bool. So we'll say public bool flee mode. Set it equal to false. All right. So the idea behind this is that this is false if we're doing the seeking, and it'll be true if we're doing fleeing. All right. Now all we have to do is apply this boolean here, and we'll use the editor to specify whether this is true or false. Is to go down to this line of code here. All right, and we're going to put this inside an if statement. So we're going to say if flee mode equals false, then we'll just do this line as is. All right, I'm going to copy and paste this line. I'm going to make a duplicate of this line and put this inside an else. So we'll say else there, and we're going to modify the else such that we're going to say -1 times velocity there. All right, so now if it's flee mode, all you do is just negate the position and the character will run away. That's all we have to do. Okay, so I'm going to hit Control S to save this. Let's switch back to our editor. And what we'll do is we'll wait for it to refresh. All right. And you'll see that flee mode is just a checkbox. And hit the checkbox there. Check it off. Let's hit run. Let's see this thing in action. All right. Now you see the cube is running away. And I'm going to actually move it around here. Now you'll notice that the cube is changing direction. All right, kind of lost Fembot there. And see if I can just double click on the cube there to bring it into focus. And let's... There. Maybe that zoomed out view will help you up. There, kind of, I know they were seeing Fembots trying to chase down the cube. But you see the bottom line is that it is fleeing. And I'll just hit pause. Let's bring cube back into focus. Try again. All right, but the idea is that you can see that the cube is running away, and it changes direction. It's actually changing direction based on where Fembot is. So you can see here that this is fleeing. So we've just implemented seeking and fleeing, and now what we're going to attempt to do is pursue and evade. So what we're going to do is I'm going to bring in the editor of the completed project just to show you pursue and evade. But the idea behind pursue and evade is that they sound the same as seek and flee, but they're different. So let's start with pursue. Pursue versus seek. The main difference between seek is that you're just heading towards where the target is. Pursue is trying to predict where you're going to go. All right. So pursue. So if I have my hand here and I want to head, so seeking would just head right to there. But if I'm moving, say this way, then my character should be actually going to where I'm trying to be. That's the idea behind it. We're trying to meet somewhere there. So in pursue, you're trying to predict where you want to go. All right. So the idea behind it is that we're trying to make the AI a bit smarter. So pursue in a way is smarter than seek. So I'm just going to hit my game script object. I'm going to uncheck seek and flee to disable seek and flee. I'm going to enable pursue evade. And we're going to follow a very similar idea here. So I'm just going to adjust the view here so you have something better to see, an easier view. There we go. And let's give this a run. All right, now you see that the cube is heading right to Fembot because I haven't moved Fembot. So the cube is trying to be a bit smarter here. It's trying to predict. Now, I didn't go too heavily into predicting, using the proper tuning variables to predict, because it looks a little bit like seeking still. But the idea is that it's trying to actually think ahead. And the nice thing about pursue versus seek is that the code is very similar. The algorithm is very similar. There's just a slight modification to getting to think a few steps ahead. And actually, that's really what you're doing, is you're modifying the code to think a few steps ahead or a few seconds ahead. All right, so that's pursue. Now, evade, if I check off the checkbox, you notice that it's running, right? So it's actually similar to it, but it's actually trying to think further ahead. It's similar to flee. So evade is similar to flee, but it's actually trying to be a bit smarter by thinking further ahead. It's actually trying to do a flee move, but a few seconds ahead into the future. So it's actually trying to jump ahead in fleeing. That's the idea behind pursue and evade, is that They're very similar to seek and flee. They're just trying to think a few steps ahead here. So looking now, what we need to do is we're going to add a new script. So I'm going to actually, we're going to add a separate script to do pursue evade. So you have a separate reference, even though it's basically this, it's a very similar code, almost identical, with only the nuances you need to solve for pursue evade. But it's good to have a separate reference, and you saw how we can separate the movements that we want. So let's add a new script. It's going to hit C# script, and I'm going to call this pursue evade script. Maybe you want to have separate scripts for pursue and for evade, but that's totally up to you. I'm gonna merge the two again, like I did with seek and flee, to have a very similar script that way. And what we'll do is I'm not gonna retype the entire block. I'm actually gonna copy and paste the code from seek and flee because it's a very similar script there. So let's just double click on pursue evade. Let's get it open. All right, and let's start with the variables. We're going to use the same variables as before. All right, so I'm going to take those variable definitions and put them into pursue evade. All right, and we're not using flee. Let's actually rename flee to evade mode. All right, and we know that velocity in the start will be velocity equals vector3 dot 0. Right, so we're starting off with that. Now in terms of update, maybe it would be better to have a good review of what we're doing again, even though it's basically the same code. We know that we want to have vector3 desired velocity equals target dot transform dot position subtracting character dot transform dot position. Right, but you can copy and paste the code. I'll retype it and re-explain it. Now, what we want to do though is this next line of code, instead of copy pasting, what we're going to do is we're going to rewrite it. The idea is that our desired velocity should be normalized and times by our max velocity. That's what we have here in seek and flee. Right, we're just going to say we're going to normalize it and times it by max velocity. What we're going to do instead though is pursue, like I said earlier, is trying to predict the next move. So you want to think a few steps ahead. So what we're going to do is we're going to predict the next position rather as well as normalize it. So first let's make our prediction. We're going to say float pred is equal to desired velocity dot magnitude divided by max velocity. All right, so we're doing a little prediction there. Now we want to work this prediction, this number of steps ahead, into our desired velocity. So now we're going to continue on what we had before. We'll say desired velocity equals desired velocity dot normalized times max velocity, also times pred, our prediction. Now we can continue on with our steering force. All right, so now we can continue on with the way we did with seek and flee. We can say vector3 steering is equal to desired velocity subtract velocity, so just like before. Now we're going to clamp it to our max force, so we'll say steering is equal to vector3 dot clamp magnitude for steering and max force. All right, and then finally we'll scale it by our mass, so divide it by mass, so we'll say steering slash equals mass. And like I said earlier about my discussion on mass, it still applies. You have a big burly character, you use a heavier mass. You have a tiny little roadrunner, you use a lighter mass. Right, so you can fine tune it to be the as you need to for your game. All right, now let's clamp it down. Let's clamp down our velocity by saying velocity. So let's apply the steering force to our velocity by saying velocity is equal to vector3 dot clamp magnitude of velocity plus steering comma max velocity. All right. We'll apply evade after. Let's just focus on getting pursue up and running. So we'll say character dot transform dot position. Actually, we've already got the variable up and running. Let's just use the if statement, get out of the way. We'll say if evade mode equals false. So evade is the opposite of pursue. So we might as well just get it done. So we'll say character.transform.position plus equals velocity times time.delta time, right? Else, we'll just do the negative of that. So we'll say -1 times velocity. All right. So we factored in evade. So evade, just like flee, is the negation of pursue. Right. So all you do is just negate pursue, and you've got evade. Right. It's that simple. Now let's apply this to our character. But before we do that, I still want to clamp the y to 1. So we're going to do this extra line here. So we'll say character dot transform dot position is equal to new vector 3, and we'll just repeat our character's x. So we'll say character dot transform dot position dot x. We're going to clamp y to 1, and z will just be character dot transform dot position dot z. All right. Finally, now we have our new position that we want to go for our character. Let's push our character forward so it doesn't just appear there. It'll just push forward or move forward to the new position in a linear way. So we'll say character dot transform dot forward equals velocity dot normalized. All right, and that's it for pursue and evade. Okay, now the trick is to apply this to our game in the editor. So we hit Control S to save. All right, now let's switch back to editor. All right, and let it refresh there. And what we want to do is we want to click on our game script object here. We added seek and flee to it. I'm going to add component again. This time we'll say pursue and evade. All right, so now we got pursue evade script. So character and target are same as before, cube and fembot idle. So I'm going to drag my cube. All right, and fembot idle. And let's leave evade mode unchecked. You can play with the mass velocity, and max force on your own to see what works nicely for you. I'm going to now you see I've lost focus. So I'm just going to double click on cube, actually double click on fembot idle, and there's both. Let's just adjust my view there to stand out a bit more. There we go. All right. And now let's give this a run. So let's open game view there. We'll hit the plus sign. Actually, I'll make sure game script is highlighted because I may want to click on evade mode as well. Oh, and don't forget to uncheck seek and flee. Make sure that when you add pursue evade, uncheck seek and flee, just so you don't have two things moving at the same time. Well, I've got fembot in the cube, so let's play around with it so you can see that. All right, and so you can see that it's still following, it's pursuing it now. It's trying to predict where it wants to go, but unfortunately I'm not playing with it. There we go. So now, so it's actually trying to keep up with fembot. Fembot's moving much faster for it to do that, but that's the idea. Is now it's doing a pursuit, and you may want to play around with the tuning variables to see just how fast you can get this thing to go. All right, so let's pursue. Let's get it to run away. So now it's going to run away. All right, and it's trying to predict, or there we go. Let's get it back into there. Get back into the view. It's trying to evade as much as possible, as quick as possible. So there you go. There's pursue and evade. All right. So the last AI feature that we want to do is called wandering. Now, you notice that as the cube was moving to pursue or to evade or to seek or to flee, it was doing it in a linear manner. And we as people, we don't walk perfectly straight. We tend to sort of swagger side to side, or like you know we don't, or strut like side to side. We don't go in a perfectly linear motion, and most creatures don't do that either, right? Even vehicles don't necessarily do that too. Like an airplane that's flying across the screen doesn't just fly across the screen. It might just sway, right? So sway a bit, right, because of external forces. This is called wandering, right? In AI, we call it wandering. We want to apply a wandering motion to our character. So now, with wandering, what we're going to do is we're not going to use fembot for this third one. We're going to actually add a sphere, and we're going to actually put the sphere, get the sphere to spawn at different spots so that it actually is following, and so that we can get the cube to follow, and in a wandering manner, randomly, the movement of our sphere. So what we're going to do is we're going to go to game object, 3D object, add a sphere, and the sphere is good there. I'm going to move it over a bit, and let's change the color as well. So I'm going to change the default. If you can, just change it to a different color, right? So I'm just going to choose one of these other materials here, and that's the idea behind it. I just want it to be a different color, right? So we have here our sphere, and what we're going to do is we're going to add a new script to do our wandering, and our script for wandering will follow the seeking ability. Let's first get our quote unquote seek up and running without the wandering, and get it to follow or get it to seek out the sphere in random positions. So let's add a new script to our project. I'm going to call it wander script, and we'll open up in Visual Studio after it's done refreshing. All right, so like I said, we're going to recreate the seek script, but inside wander. So I'm going to copy and paste from seek and flee this time again. So we'll just take without the flee mode, because we're not dealing with fleeing at all. Just going to do wandering. So I'm going to copy character and target. Just copy the whole thing and then delete flee mode. All right, let's get rid of that bool there. We don't need it. We'll need to add a few extra variables though, which we'll do afterwards. So we got our variables here. Now from start, we just needed that velocity is equal to vector3 dot 0. All right, and in terms of update, let's just take our exact same seek script. All right, paste it into wander. But since we deleted the flee mode variable, we have to get rid of this if block. All right, and the else as well. And let's just line this up proper. Okay. All right, so now we basically just have a seek script inside our wander. All right, we're just going to follow seek. You can follow pursue if you wanted instead. The idea is that we want to do some wandering. All right, and I don't want to call it target. I want to call it wander target. So I'm actually going to rename the variable. To wander target. That'll cause an error, so let's fix that. All right, and yeah, so basically we just have a seek here. Now let's modify this script. So instead of us chasing fembot, we're going to chase that sphere, and we want that sphere to appear in random positions all along. All right. So we're going to create a method called next waypoint. I'm going to put it right here just above update. So we'll say private void next waypoint. All right. And what I want to do is I want to change the position of wander target. We'll do it every second or so, or every few seconds. And we want to restrict it to be within a range within reason. So I'm actually going to, if I switch back to the editor for a sec, I want to keep my sphere to spawning within this radius here. And I've already done the numerical calculations figured out. So I want to keep x between -15 and +15. I want to keep z between -6 and +6. Y will always be 1. All right. So I've already looked at you know the transform positioning of the sphere, and I've already figured out that x and z will be within those ranges, and that's good enough for where a sphere can be. So we'll just focus that for our environment. Of course, if your environment's different, you want to try and figure out, you really want to try and figure out, you know, where my mouse is along this area and along this area, right? So you have like a little sphere and a square, right? So, but that's based on what your environment is set up. Okay, so that's why these numbers may differ for you. Okay, so let's start by saying vector3, call it 1 equals new vector3 and we'll clamp the range. We'll generate a random number first of all and restrict it between -15 and +15. So we're going to use random. Say random, capital R, dot range, and we'll say minimum value will be -15, maximum value be +15. All right, so that'll be for our x, comma, y is always 1, comma, and z will be between -6 and +6. So we'll say random dot range for between -6, comma, +6. All right, so that's our this is supposed to be our new position for where our sphere is going to appear. Now all I have to do is just say wander target dot transform dot position is equal to 1. All right, I could have just done that in one line of code, but whatever. All right, so we have here a method that will change the position of wander target. We want this to run repeatedly. All right. Nice thing about Unity is it actually has a nice method to invoke a method repeatedly. It's called invoke repeating. So we'll go to start, and we're going to have this method next waypoint repeatedly running automatically. We could have done a coroutine to do this ourselves, but then this actually saves a lot of work in doing that. So we'll say invoke repeating the name of the method in quotes. So next waypoint. It's case sensitive, so be careful with that. Comma, the time. So we'll start it after 1 second, so 1.0 f, and repeat rate. So how often to do this? We'll say 5f. All right. So every 5 seconds. So we'll start this after 1 second. All right. And then we'll do it every 5 seconds. We'll invoke this method called next waypoint. All right. Now let's apply this without wandering. Okay, so I'm going to Control S to save. All right, let's switch back to our editor and get everything up and running first of all without wandering. All right, so now let's add this new script, wander script, to our game script object here. And what I'm going to do is I'm going to hit add component, and we'll say wander script. Now what we want to do is we want to uncheck seek and flee, and I should have unchecked pursue evade last time, or uncheck seek and flee last time, but I did that inside the game, so it didn't remember to do that. So uncheck seek and flee, uncheck pursue evade, and just have wander script. And we're going to do character will be our cube. wander target is our sphere. All right, now let's run this and see. Let's see it in action on its own. We don't really need the game, but we'll see everything in action here under scene. All right, so now you can see that the sphere every 5 seconds will move to a new position. All right, and you can fine tune that. It looks like 5 seconds might be too long. So maybe we'll change that to 3. But let's see here. So it gets there, and there you go. Now it's changing position. All right, so it's seeking out the sphere as it goes. What we need to do is we need to now apply wandering to this. All right, so it won't just walk in a linear manner. It'll be kind of like strutting. Now, the thing about walking towards or move or seeking out the object is that we're gonna, the way it's designed, wandering is designed is that you try and move like this, right? And this is kind of a circular fashion, all right? And when you're doing it this way, while moving, like you see me moving my hand here, you end up trying to adjust the facing of the cube in a circular manner, in a way that you're applying circular circumference, radius, distance, and so on, so that actually is changing the angle of facing. Right? That's actually what we're doing here when we're walking, right? And so that's what we're going to apply right now to our cube. So we're going to modify our wandering script to add in a bit of wandering here. So let's jump back to our wander script here. And let's add a few extra constants here that we can work with. They can fine tune on your own after you're done this. We'll say public float circle distance. We'll set it equal to 6. Public float circle radius equals 3. And then public float. So like I said, we're dealing with a circular motion here. So we'll say circle distance, circle radius. We'll need something called wander angle. Set it equal to 15, so an angle of 15 degrees. And we'll need finally a public float angle change. So how much do we want to change the angle by in each iteration? Let's say 5 degrees, just to start off with. Maybe a smaller number is better. It'll be up to you to fine tune and see, depending on your object and how you want to go. All right, let's create a method that we're going to use inside our update afterwards to adjust the wander angle. We'll call it wander. So we'll say private vector3, and return back a new vector3, wander, passing in a vector3 called velocity. All right. Now, like I said, we're dealing with a circular motion here. So we'll start by creating a vector3 called circle center equals velocity dot normalized. All right. Now we'll scale this circle center by distance. Okay, so we'll say circle center star equals circle distance. All right, the circular distance scalar we set up above. Now we'll need to figure out the displacement force, is how much we want to displace our, and we want to apply a force in displacing our where we're facing. So you can see with my hand here, we're going to calculate the force for it. So we'll say vector3, just scroll up a bit here, vector3 displacement is equal to new vector3. We're going to clamp it to 1. So we'll say between 0 and 1. So we'll say new vector 3, x will be mathf dot clamp 0, 1, to clamp between 0 and the number, so 1. All right, we'll keep y as 1 always. All right, and z will do the same thing, math f dot clamp 0, 1 for 1.0f. All right, now let's apply this displacement force to our circle radius. So, apply our circle radius to displacement force by saying displacement star equals circle radius. All right, now let's now we want to do is we want to change the angle at which we're doing this. So we're going to, before we do that, we're going to create a new method to play with the angle at which we're facing. So we'll come back to this method. We'll add some more to it. We'll say private vector 3 set angle is equal to vector 3 vector comma float wander angle. All right, and inside of this is where you actually can fine tune your wandering, whether you want to go this way. We're actually gonna go like this way, but also like this way. All right, so kind of like a nodding motion as well. So we're gonna walk and nod, walk and nod, like it won't just be this way. It'll be like this way, up and down, right? So kind of like a more realistic human movement where we're actually just kind of like up and down, but also like side to side. That's really how we move as people, right? So we want to apply that to our cube here. So that's why we're gonna set our angle in 2 directions, in x and z. Y will always stay the same though. So we'll say vector 3 v equals vector, the one we've passed in. Now we'll say how much we want to scale by or adjust the angle by. So we'll say float len equals vector dot magnitude. All right, now let's apply it to both our x and z portions of components of our vector here. So we'll say v dot x is equal to math f dot cos of wander angle. All right, scale it by len. All right, v dot z is equal to math f dot sine of wander angle, and scale it by len as well. All right, finally return v. Okay, this will be our method we're going to use to adjust the angle of displacement of our character. Okay, now let's apply this back to our wander method. So now we're going to say displacement is equal to set angle of displacement comma wander angle. All right, and so now let's adjust the angle of our and force. So we'll say wander angle. So wander angle will constantly be changing. Will be plus equals random dot range between 0.01f and 1.0f. All right, times it by our change in angle, so angle change. Right, subtract it from, so we're going to change our angle change as well. So we'll say angle change times 0.5f. All right, so what we're doing here is we're going to also change the wander angle, and we're also going to change it by our angle change. So wander angle will be, even though we hard coded to 15 to start off with, it's going to actually be changing based on, so it'll be like a plus or minus 5. All right, so maximum plus or minus 5. So between 10 degrees and 20 degrees is what we're doing here. All right, because we set wander angle initially to 15. All right, so it'll always be changing. Now let's apply this change to our force. So we'll say, and we'll return it back. So actually we'll say finally vector 3 wander force is equal to circle center plus displacement. finally return wander force. Okay, so we've done all this calculation here. So we've done all this calculation here to adjust angles, to adjust movements, you know, to sway up and down and side to side, right? So we've done all this adjustment here. Now let's actually apply this to our character. So the question is, how do we apply this to our character? Well, it's actually not that big a deal here. What we're going to do is we're going to scroll up to our update, and let's look at steering. Okay, so now we're saying vector 3 steering is equal to desired velocity minus velocity. Let's modify this. We're going to actually say vector 3 wand is equal to desired velocity minus velocity. And then we're going to say vector 3 steering is equal to wander of wand. And that's it. We're done. So now we've basically just circumvented our steering by applying wandering to it, right? So you can see that it's just that simple. Like, to be able to apply wandering, you just update accordingly. The trick, though, is actually creating or formulating your wander algorithm so that you're doing the wandering that you want. And in particular, wander itself will stay the same. It's the set angle method that we had at the bottom that may change depending on your application. So this method may change depending on, you know, are you applying to X, to Z, to Y? Are you doing a cos, a sine, right? So this is really the bread and butter fine tuning, where the fine tuning will happen. All right. So after we've adjusted these two lines here, all right, now let's apply this in our game in the editor. Okay. So we've already connected everything up. All right. So if I switch over to my editor here, well, first let's actually save our script. We haven't saved the script yet, so back here, do Control S to save. All right, now switch to editor, let it think. All right, now all I have to do is just hit run. All right, and so notice the cube is kind of jittering, kind of shaking. It's like left to right. It's not going perfectly linear. It's kind of like it's chugging along, right? So that's what we're trying to do with wandering here, right? It's seeking out the sphere, but in a not in a perfect manner there, right? That's what we want. We add a little bit more realism to our game, right? So there you have it. We've just investigated 5 AI algorithms for steering in the steering category. So the idea was to steer to our destination, right? We looked at seeking, then we looked at fleeing being the opposite of seeking, so it was really easy to do. We looked at pursue. Pursue is very similar to seek, except the difference is that you're trying to predict where you want to go. So like in hockey, you don't pass the puck to where the person's standing, you pass the puck to where the guy's going to be. So that's what we do with pursuing. We try to predict where we want to go. And evading is the opposite of pursuing. And finally, wandering. So we added a little bit of jittery movement, a little bit of, you know, strutting to our character. All right, so that's it for steering methods in artificial intelligence in Unity. Don't forget to like, subscribe, and I'll see you in the next tutorial.